Okay, so a very good afternoon to all of you, all the participants here.
Very good afternoon.
Thank you for sparing your time and attending this short awareness session on confined space entry safety. So on behalf of KBS, we welcome all the participants. Before we start discussing the subject and the hazards and controls related to the confined space entry work in any industry, I would like to quickly introduce myself and the company. I am Rajesh Parekh. Many of you might be knowing me, might have interacted with me during assessments and other trainings. But for the sake of other participants who have not met me so far, as I said, I am Rajesh Parekh. I am heading the sustainability division at KBS. Now we also call it the ESG and sustainability, the environment, social governance and sustainability division. I'm a chemical engineer by my academic qualification, and then I have my professional qualifications in health, safety and environment, having worked in the chemical and pharmaceutical industry for almost 10 years in the operations and production department, and last 20 years, you can say almost 20 years now, I am in the field of third party companies like KBS. Earlier I was with DNV, with TUV, SJS, RENA and so on, and have worked in the capacity of we are ISO based management systems assessor, trainer, and also in the last 10 years I have spent on sustainability related assessments, sustainability report verifications, and so on. I have conducted more than 2,500. I mean, honestly, I have stopped counting now. More than 2,500 mandates of audits in Asia, Africa, few of them in Europe, and more than 250 training programs, awareness training programs, lead auditor courses, and so on. So that's about me. I've been working with KBS for the last 1 year now, and I'm basically based in Vadodara, but travel across. As far as KBS is concerned, KBS is a third party certification, verification, assurance providing organization founded in 2005, right? With the basic objective to provide trainings, independent assessments in diverse areas of management system certifications. KBS is a leader, world leader, currently in the climate change services, CDM, the carbon credit verifications and all other climate change related services. We have started the sustainability report assurance services, product certifications like CE marking, and the third-party inspection services. It's accredited. The management system certification part is accredited by the Australia-New Zealand Joint Accreditation Service Board, and as well as the EIAC from the United Arab Emirates, Middle East. We have accreditation from the National Accreditation Board for Certification Bodies in India for the GHG certification, the ISO 14065 and the Z schemes, accredited by the United Nations Framework Committee on Climate Change as a DOE for validations and verifications of all the CDM projects, the carbon credit projects, climate change projects. We have the AA1000 accreditation from Accountability UK for sustainability report verifications and assurance services. We are an approved CQI IRCA training partner and authorized to provide trainings on all the various management system Lead auditor courses for like ISO 14001, ISO 9001, 45,001, 50,001, and so on. The quality, safety, environment, energy, food safety, information security, and so on. Also approved by the Bureau of Energy Efficiency as a ESCO company to do energy audits, right? Also a notified body for CE marking product certification, and also for the automotive industry certification 16949 in collaboration with Applus Laboratories. So we have a big pool of auditors in-house as well as contractual, and more than 7,000. I think this might be an old number. Currently might be more than 10,000 customers for various services. Right. So these are the main services, as I already shared with you. Sustainability ESG services has been recently introduced since I joined, but we have a very good foothold in the climate change services, management system services for the past almost 20 years now. Trainings, management system trainings, lead auditor trainings, internal auditor trainings, awareness trainings, third-party inspection services, and so on. Right. So these are the list of the approved lead auditor, internal auditor trainings that we have through CQI, IRCA. These are the accreditations that KBS holds. So we are basically one of the fastest growing third party, as I said, assurance, verification, inspection, training, testing companies. We have offices in India, in UAE, and few other countries. We have our collaborations. Now, coming to the subject, confined space entry. As we all know, in any industry, whether it is a manufacturing sector, whether it is a hotel industry, whether it is a governmental service provider, whether it is any sector, buildings, our residential buildings, commercial complexes, all these places we have these confined spaces, and we have at times people, workers entering these confined spaces to perform certain jobs, to perform certain duties, and most of the times they are not aware of the hazards and the risks involved in the job, the risks and hazards involved in the space where he is entering, and thus we have so many accidents, fatalities across the world every year. Like, just to emphasize on the fact, I'm just sharing on the screen few of this, information or news which is available on the net. We have had a lot of, in India, we have had a lot of confined space deaths in the sewer cleaning activities, manual scavenging, as we now know. Now we also have a legislation to ban manual scavenging, but still contractors, they do send people inside these sewers, and these sewers have a lot of hazards like oxygen deficiency, methane exposure, and we have a lot of people dying, losing their lives every year. A lot of people entering reactors, vessels, tanks in industry without understanding the risks, without having proper controls, proper controls, which we are going to discuss later on, and they meet fatalities and other serious accidents. If you see from some of the Bureau of Labor Statistics data, in 7 years from 2011 to 2018, we have more than 1,000 people dying. These are all reported incidents. And as we all know, unfortunately, in our country, there are a lot of incidents accidents which go unreported. So confined space entry is one of the most hazardous and dangerous activities carried out in any industry, apart from others like work at height and other such activities. Confined space is one of the biggest killers, and we need to take this very seriously. And in our industries, we need to have proper understanding and then proper control over the hazards and risks associated with confined space entry. Participants, you may please feel free to intervene me at any time during the during my narration, because I could not see you. I'm on a full screen. So please stop me at any time you want to ask me a query, or you want to throw some light, share your experiences on this particular subject. Please feel free to do so. Let us make this more interactive session for the benefit of all of us. And also I would know that I'm still audible and you guys are able to hear me and see me. Hear me and see the screen. Now, one of the, as per my experience of industry, one of the biggest hurdles is people do not understand what is a confined space. How do we define a confined space? What is and what is not to be considered as a confined space? Anybody would like to share his idea or point of view on what should be a confined space and what should not be? Anybody? Any volunteer?
Yeah, hi. Thank you very much. This is Murli here. Hi, everybody.
Hi.
As far as the confined space is concerned, yes. So what we see in the PowerPoint presentation, yeah, most of them are from the OSHA E 1910. But one of the factors we may have to add in mandatory is, after the third bullet point, is not designated as a place of work and what? As a place of regular residence. Many workers consider the confined space is a closed enclosure, so they consider that as a temporary residence. If we see OSHA regulations, it very clearly says it should not be used as a confined space. I'm talking about OSHA CFR 1910 146, please. That you may consider adding, please.
Definitely. That's a good point. Yes.
Welcome.
Right. So, as we see on the screen, a confined space is a space which is a enclosed space. It could be 100% enclosed, fully enclosed, or partially enclosed. A place where you need to apply the following mandatory points of definition along with any one of the other three mentioned over here. So if any space meets the criteria of these three mandatory and any one of the following non-mandatory steps, one of the points, that place has to be designated and identified as a confined space. Like, confined space will be any space which is large enough for a person to enter. So it has to be at least of that volume or that big enough for a person to completely enter into that space. Along with that, it must have a limited or restricted means of entry or exit, like the one you see in the picture, through a manhole or through small channels or those kind of places where it's not like the door of your office or your home, where you can simply enter and come out at your will without any problems or without any obstructions. Also, it would be a place which is not designated as a place of routine work, a place where you don't work your regular working hours. You only go there at times when a non-routine job has to be performed. Either it is a maintenance, a cleaning job, a repair job, or those kind of jobs. And as Mr. Murli rightly said, not a designated place for full-time occupancy, residence, Yes, sir.
Thank you,
Now,
sir.
in addition to these 3 points, one of these other criteria also must be fulfilled. Like, the place may have an atmosphere which contains potentially harmful levels of toxic or explosive atmosphere. So when we say toxic, that means poisonous or toxic gases. Like, you could have methane, you could have hydrogen sulfide, you could have sulfur dioxide, acidic fumes, and many other toxic and poisonous fumes, vapors. And it may also have an explosive atmosphere. How do we define explosive atmosphere? How do we identify whether there is an explosive atmosphere in a confined space or not? Anybody? What is the measure? When you use your gas testers, what does it show? It shows something called as a LEL. What is that LEL?
Low explosive limit.
Yes, correct. It is a lower explosive limit. So every volatile liquid, every volatile organic compound has a a flammable compound mainly has a lower explosive limit and a higher explosive limit defined for it. This is basically a percentage of mixture with air, right? So the lower limit is the minimum amount of that particular vapor along with air, and the higher limit is a maximum level of that particular vapor in mixture with air. So atmosphere is considered to be explosive when the level of this mixture is between the LEL and the HEL, the higher and the lower limits. So that is what we check. If the mixture is above, if the reading is above the higher level, that means the concentration of air is much more than the vapor, is much more than the high. There won't be any explosion. And if it is lower than the lower limit, that means the concentration of that vapor is weak. So that is what we also check. So this could be the one of the possibilities. Either there is a toxic atmosphere, explosive atmosphere, or there could be a deficiency of oxygen. You may not have a safe level of oxygen. What is the safe level of oxygen? What is considered as what is the range of safe level of oxygen in air?
20.5, sir.
19.5 to 23.5.
Exactly. 19.5 to 23.5. Why do we have upper limit of 23.5? Shouldn't it be great if we have more oxygen? In the last 2 years, we have been all fighting for oxygen. So ज़्यादा है तो क्या problem है? I mean, why we have that limit? Why do we say that it is hazardous to have more than 23.5? Anybody? Any guess? Okay. The reason we have this, I will show it in the next slide. It's there over here. If you see this particular oxygen level picture, if you see, we consider 19.5 to 23.5 as a safe range. Above that, the more the oxygen, there is a increased risk of fire. And 100% oxygen can also lead to brain-related issues, brain damage. And lower than 19.5 can cause, increased heart rate, drowsiness, nausea, unconsciousness, and even death. So that's the reason. We don't want more, we don't want less, we want it in that particular range. And finally, to fulfill the definition of a confined space, if there is a possibility of entrapment or engulfment inside the confined space, we may also consider it as one of the criteria. Like you are the confined. Yes, please. Like, what could be the examples of entrapment and engulfment?
Entrapment may be because of any set of workers working in a quarry or a road construction and repair. The land slide may also cause entrapment.
Correct.
Engulfment may also happen where people, workers working in a timber company in large scale, suddenly the trucks come into a sort of an accident or the timber rolls, so lot of timbers getting unleashed from the truck may relate to engulfment.
Right.
I'm not sure about engulfment, but I thought I'll share whatever is in my mind. Thank you.
Yes. Yes. So yeah, you have given the right examples. Other examples could include, like when we do excavation work, as you rightly mentioned, there could be a soil collapse, and we can have people entrapped in those excavations. Then many a times we work in confined spaces, we go into those spaces like in vessels where already there are other equipments, like other things like baffles, like the reactor stirrers, agitators. So people can get entrapped below those other equipments in that particular confined spaces also. So there are many examples, and sometimes the confined space may have some kind of a marshy, kind of a sludge, or those kind of material which can engulf you, and it makes movement during rescue difficult for you. These are various examples. So as I said, if in all the mandatory requirements and any one of the following is fulfilled, you must identify that particular area as a confined space. Now, what are the major hazards in a yes, please.
I would like to share one more situation which I came across in one of the harbors where the containers are loaded, kept for to be loaded in the ships. Customs authorities come and open the checks at random for many checks. At that point of time, some workers working between the containers and some other operators using the forklift or any other heavy lift crane try to lift the containers. Some workers may get trapped between the containers. It's not only the accident. For example, some group of people are working between the containers in a confined space. Some of them may face injuries and fatalities, but some of them may get entrapped without even scope for them to even shout or make a noise because lack of monitoring, lack of application of regulatory requirements. These things can also happen. Thank you.
Yes, they do. I mean, in ports, I have audited many of the ports. People go in to take samples, especially those bulk carrying ships like coal or food grains, or people go inside the chambers to collect samples, and they get entrapped due to oxygen deficiency and others. Yes, even the ship this ship cutting recycling facilities in Alang and other areas, where people go inside confined space to cut open the ship and all the vessels and tanks inside the ship. There are a lot of incidents in this industry with respect to confined space. So the major hazards in a confined space are, as we already discussed, one is the toxic atmosphere, right, where the workers can be exposed to immediate acute effects, including impairment of judgment, unconsciousness, and even death. And in fact, if you go through the accidents which have taken place in the last so many years, you will find in many of the cases, the people or the persons who go to rescue a trapped or an unconscious worker in a confined space, they also succumb to the same kind of injury and sometimes fatality, because they don't take protection against the toxic atmosphere. They don't use the respirators or self-contained breathing apparatus. They don't use the right rescue tools, and they just jump into pull that person out, and then one after other, it's like a dynamo chain and cycle, and everybody there have been many cases. If you go to YouTube and all, you will find in oil and gas companies, especially where there is lot of confined spaces have this methane and hydrogen sulfide related risks. One after another, rescuers go to rescue others, and they themselves become victims of the incident. The other major hazard is oxygen deficiency, as we have discussed. Anything below 19.5 will be considered as oxygen deficiency. So we are not supposed to enter a confined space or let anybody enter into a confined space when the levels are not between this 19.5 to 23.5. Sometimes oxygen enrichment also, as we said, more than 23.5 also is the risk, mainly the fire related risk. Other hazards, like there could be a possible of flammable or explosive atmospheres inside the confined space, presence of vapors, fumes, remnants of explosive and flammable, volatile gases, liquids, fluids. Sometimes flowing liquid or free flowing solids. If we do not properly go for isolation of all the energy sources getting into a confined space, like all the incoming inlet pipelines, electrical energy, potential energy, mechanical energy. If you don't do proper isolation, the person inside may be subjected to those energies also. And sometimes excessive heat. Heat maybe because that vessel or tank was jacketed and heated earlier, and it has not been cooled down before you make the entry. Or sometimes if you are performing a hot work, a welding or a gas cutting work inside a confined space, the heat created by the hot work. So these are all the major hazards in a confined space. If I have missed any, please feel free to add on to if I have missed any other hazard you feel, apart from that entrapment and engulfment, which we have already discussed.
Thank you, Mr. Rajesh. I would like to add whatever you said. Thank you very much for sharing your experience on major hazards in confined spaces. The last point only I would like to add, in addition to excessive heat, excessive chillness also could cause major hazards, such as
Exactly.
food manufacturing organizations where there are frozen departments below 4 degrees centigrade. And those workers, particularly working in night shifts, they think they are the masters, they are competent, but late night shift levels of supervision monitoring may be less, and people may get exposed to excessive chillness and get into this. This is one example. Another example is where snow-filled areas, ice forming in the atmosphere, in remote areas where the workers go using specific ice breakers, using mechanized bulldozers to remove them. they also may get exposed to such one, because I'm talking about remote areas where there is less people around. Even if someone shouts for help, there is no scope for the person for a relief. So these are the two examples of excessive chillness as well.
Exactly.
Thank you, sir.
Yes. So as Murali sir has rightly said, apart from excess or higher temperatures, lower temperatures also a risk. Many of the industrial operations are, they work in cryogenic conditions, very low temperatures, even more than minus 100 degrees centigrades. Many of the food, pharma, other industries, we have, storage areas, huge refrigeration units, chillers, where the temperature is below 0 degrees. So yes, frostbite is also one of the risks in these areas. Now we have discussed what is a confined space. We have discussed the major hazards in a confined space. So now let us talk about what should be the controls so that people who have to work in confined spaces can work safely. So the few of the basic controls that comes to mind, the first and foremost mandatory, in fact a statutory requirement also, is that no work in confined space should be carried out without applying a formal permit to work system or a work permit system, whatever you may like to call it. Every industry which has confined spaces must have a formal work permit system, and every time a person has to enter a confined space before or perform a job in a confined space, a formal permit must be obtained with all the steps followed without bypassing any of the permit steps. Permit, ideally, I would say, what I have seen the best practice in industry is that you normally have your cold work permit, you have your hot work permit, and apart from the cold work permit, you have special permits for high risk activities like confined space, work at height, excavation, and so on. So you must have a special permit for confined space entry, which addresses all the hazards and controls in that permit, which allows you to record each and every entry and exit of each and every worker inside a confined space. It allows you to record the initial gas testing results, the periodic gas testing results. It allows you to record all the tools and equipments that the people or the workers take inside the confined spaces, the exit and entry time, to ensure that we don't leave anything inside when the job is over. And it should also address the minimum rescue requirements, the rescue team, emergency numbers, the rescue equipments required, and who is going to be the identified attendant or standby, whatever you may like to call it, for that particular job. Also, since it is a non-routine work and a dangerous activity, high risk activity, it is always advisable that you have a job safety analysis or a JSA, as we know it, attached to the confined space permit. So the JSA will inform all the workers involved about the specific risk, hazards, and controls, the conditions of the environment during that particular activity, the do's, the don'ts. Also, you must have a formal toolbox talk carried out at the beginning of each shift at before the start of work, and if the work gets carried forward to other shifts, if the work duration is long enough and you have a new set of workers coming in every time, every shift, you must have the toolbox talk done and the JSA explained. So this must be religiously practiced. All persons required to work in a confined space or to act as a standby or attendant, or even the members of rescue team must be periodically trained, and you must ensure that they are competent, they understand all the hazards, risks and controls of working in a confined space. Only trained people must be deployed on this kind of a high risk activity. All confined spaces must be identified. So we already know how to apply the definition of a confined space. So ideally, you must have an inventory, a list of all the confined spaces in your site or location. All the tanks, vessels, tanks, vessels, culverts, all those areas where you find the definition of confined space is applicable. You must identify them in as a list, as an inventory in an Excel sheet maybe, or any other method you would like to use. And at the entry point of that confined space, ideally you must put a permanent signage like the one in the picture at the manhole, near the manhole, so that anytime anybody wants to open the manhole and enter, he can read that this is an identified confined space and he cannot enter without a permit, just to remind the people. Before we enter the confined space or perform the job required, as part of your permit to work system, you must also ensure that all applicable energy sources, it could be electrical energy, it could be steam energy, it could be chemical energy, it could be hydraulic energy, mechanical energy, moving equipments, moving parts of equipments. All these energy sources must be isolated. So you must apply the lockout tagout system, the LOTO system. All once you put the locks and tags, you have to ensure that all the remnant or residual energy is drained out, so that the people, when they go inside the confined space, they don't get exposed. Many other times I have investigated incidents wherein isolation was performed, but the residual energies were not drained and the people got exposed to acids, alkaline solutions of high pH, hot water, steam, and so on. And they met with fatalities. So we don't want that. So before entering the confined space, lockout, tagout, or isolation is a must. All inlets and outlets that could introduce contaminants must be isolated or blanked off, including double block and bleed as appropriate. If it is a process equipment, a pipe, a tank, vessel with pipelines, you may like to go for blanking, blinding, and so on. Even for your process walls, flanges, handles, and all those things, you must have equipment like the one shown in the picture to, carry out a proper lockout and tag out. Specific safe work procedures must be developed for work activities that are more hazardous when carried out in a confined space. If you are just entering a confined space for a routine inspection or, a simple work, it's a different story. But the moment you carry out a more dangerous activity inside a confined space, the risk is higher, is exponentially higher. Like, for example, if you are going to perform hot work inside a confined space, what is the risk or hazards of, risk of carrying out a hot work in a confined space? What is the additional risk the hot work brings inside a confined space? Anybody?
Good afternoon, sir.
Good afternoon.
Here. Sir, in hot work, basically in confined space, there may be a chance of fire explosion due to that explosive gases. And in this welding work, you can imagine that release of poisonous gas also from that activity. This is the basic things.
Correct. So you may have, yes, please, sir. Sir, you are on mute.
In addition to what Mr. Saubhagya was mentioning, sometimes what having a confined space where you can carry out the hot work, not necessarily arc welding or gas welding. Any heat excessively generated in a confined space leads to first exhaustion of the person in terms of the heat, which reacts with the biological systems, either excessive sweating, and also by sweating, the depletion of energy. The person loses the energy level that is required to carry out the duty with, say, for about 1 hour, 2 hours. In other words, excessive heat drains the energy and brings in exhaustion, number one. And number two is working with the arc welding, gas welding, or any sort of such a heat producing activity that also brings asphyxiation in terms of lack of oxygen, which was not there when he started the work in the confined space. Thank you, sir.
Exactly. So when you do this kind of a hot work, now what is a hot work? As Murli sir also rightly said, it is not necessarily limited to electric arc welding or gas cutting alone. Even grinding, use a portable grinder, abrasion, shot blasting. There are many other methods, many other activities that we carry out inside a confined space, which may generate, heat, or which may generate fumes like welding fumes, or which may even generate a lot of dust. So all this will bring in new hazards which were not there when you did the initial gas testing. And that is the reason you have to have additional controls when you are doing these activities. And you may opt for a personal gas monitor attached to the person when he's working inside with the alarm. And we will just not depend on our initial gas testing and once in 2 hours or 3 hours periodic gas testing in this kind of situations. So this we have to be mindful of.
Sir, in this you are saying to fix a gas testing device with that user?
Yes, there are continuous gas monitoring devices, small device. You put it, attach it on his shoulder, which will give you an alarm in case there is any of those, either oxygen, mainly it is oxygen which they use for, but even you have those LEL related continuous monitors available. They use it in the oil and gas industry all the time.
Yes, I got your point, sir. One more thing, sir. Addition to that, as you know, in our different industry sectors, we are using initial gas testing and when the cell is unmanned, we test gas again before resuming the job. So is there any specific interval of time? Suppose, as you said earlier, we have to test initially with shift, and then we also know that when cell is unmanned, we go to test, and then again we will resume job, and again we will do the gas testing. So in this period, is there any defined to we have to gas testing in 2 hour interval, 4 hour interval, half an hour, anything else like that?
There is no defined standard to decide the periodicity of testing. Every confined space has its own hazards, and ideally you are required to have a operation control procedure or a safe work procedure for every confined space work that you do. And based on the hazards which are present, you have to make a call. The issuer of the permit has to define what would be the ideal periodicity. As a minimum, in any confined space, it should at least be once in a shift, but depending on the nature of the job and the confined space, it should be defined. Ideally, universally, if you see most of the chemical tanks, vessels, and all those kind of entries, people define once in 2 hours interval. Also, once a person enters a confined space, a person or a group of persons, they leave the confined space for some reason, maybe during break or lunch break or tea break, and there is a gap of time when the confined space has nobody inside. Before somebody makes a fresh entry, again you must do a initial gas testing.
It may be 5 minutes, 10 minutes, half an hour, 1 hour.
It could be 10 minutes, 15 minutes also. That, I mean, this is a system, best
Yes,
system
got it.
that industry adopts. Because during that period, we don't know if a new hazard is introduced. We don't know.
Yes, sure.
Better safe than to be sorry. Okay.
Yes.
Where the risk assessment has identified the need for ventilation or purging, this must be covered by a documented procedure. So, I mean, now, what happens if you do the initial gas testing and the reading is below 19.5? The nature of the confined space is such that you just cannot get that 19.5 level. So what do we do? In that case, you may have to go for
Artificial ventilation.
Artificial ventilation, or a blower to pump in more fresh air and bring that oxygen level to 19.5 and between 19.5 and 23.5. You may also like to go for other methods, like if you have 2 manholes on the opposite sides, you can also facilitate cross ventilation by opening both the manholes instead of just opening one manhole through which you are going to make the entry. So all this will be decided by the risk assessment, by the safe work procedure, by the JSA. And all this has to be thoroughly examined before issuing the permit. That is why the permit to work system is very, very critical and important in a confined space entry job. And this is where many of us, many of the industries, many of the experienced people also take shortcuts, and then they endanger the life of poor workers. Right? So as we have discussed, no entry should be allowed in a confined space without initial gas testing. Now this is a typical gas tester. If you can see on the picture, you have this is called as a multi gas meter, and it will show you the lower explosive limit and the presence of toxic gases like carbon monoxide, hydrogen sulfide, methane, and the oxygen level. So you are required to do initial gas testing and then periodic gas testing as defined in your procedure or as defined by the issuer of the permit. Now, when you're doing a gas testing, one of the major mistakes which people make, or I would say, blunders which people make, is that they buy a multimeter which has a very short probe and they only test the gases at the top of the manhole, near the manhole. But there are many gases which are heavier than air, like H2S. So when you do the testing at the top portion of the vessel, H2S will show 0 ppm, but at the bottom you have a lot of H2S. And when somebody enters and goes to the bottom, he faints. So ideally, you must have those long tubes or probes, and you must do the testing at 3 areas, top, middle, and bottom, to ensure that the entire confined space is free of toxic gases and explosive mixtures, and the entire confined space has the minimum oxygen level. All these multi-gas meters, what I have seen, ideally have a calibration frequency of 6 months. So every 6 months, you must calibrate these multi-gas meters. All confined space entry jobs, the area ideally must be barricaded with proper signage that confined space entry is going on. Right? The permit copy must be available at the place of work. Whenever the confined space is left empty, as I said, during breaks or lunch break or tea breaks or for some other issues, please put a soft barricade on the manhole with this proper signage as shown in the picture, because it's a human tendency. We are always curious, to peep inside a confined space. कि अंदर कैसा दिखता है. And the moment you put your head inside the confined space, you may be subjected to the risk of, toxic exposure or oxygen deficiency. So we don't want peepers to go around. So have proper barricading, proper signages around the confined space. For every confined space entry job, you must have a dedicated full-time attendant or standby deployed throughout the job until the time the permit is completed and closed out. And his duty will be to remain outside the confined space. He will not go inside the confined space. He will monitor how many entrants are going in, what is the timing, time out. He will guard the space from trespassers or peepers, as we discussed earlier. And during emergency, he will summon the rescue team, the emergency response team or the rescue team. Trained rescue team must be deployed with appropriate rescue equipments. So first of all, when you have confined spaces identified in your site, ideally you must have the bare minimum confined space rescue equipments with you, like full body harnesses, ropes, tripods for vertical entry and vertical rescues, stretchers for horizontal entry and rescues, self-contained breathing apparatus, blowers and all those kind of equipments. Rescue team members must be trained. Nowadays, we have certified trainings on confined space rescue available. There are agencies like Karam and many other who do a 2 days rigorous training and certify rescue team members for work at height, confined space, excavations, and so on. So those are very good trainings. Ideally, you must train your rescue team on them, on these trainings. So these are all the basic, I would say, hazards and controls required for a safe confined space entry job. Any questions or queries?
Sir, I have one question. In this total topic, we are not discussed regarding that illumination inside a confined space, I think. Yeah, maybe I skipped.
Yes,
I
yes.
joined little bit.
That's a very valid input.
So
Illumination is also a hazard. Poor illumination is also a hazard. So we have to ensure that we have adequate illumination inside the confined space. And if you require to take a portable, bulb or illumination equipment inside a confined space, it should not be more than 24 volt DC current equipment. So yes,
sure.
rightly pointed out, illumination is very, very important. And also we have to make sure the illumination equipment that we bring in is of 24 volt DC and lesser.
What about manhole dia, sir?
Manhole dia,
16 inch.
see, as we said during the definition of confined space, it should be large enough for a person to enter. So if the manhole dia is not big enough for anybody to enter, then it doesn't qualify as a confined space in the first place. Did I answer your query?
Yes, sir. Yes, sir.
Anybody else?
Yeah, thank you. I may like to add, when you mentioned the confined space is defined as which should have a proper entry for a person to carry out his work in the confined space. And it is not limited only to entry, also for exit as well as a routine exit. Thank you, sir. Exit as a routine and also exit in case of emergency. In case of emergency, we expect a little more space than actually we would normally exit in a routine after completing a work. This also I thought I will add. Thank you, sir.
Exactly.
Exit.
Because that's a very valid point, because during entry, we just wearing a harness and going inside, or we may not be even wearing a harness. But during rescue, the rescuer might be wearing a self-contained breathing apparatus.
Right.
Plus, he has to carry tools with him, maybe a ladder, a stretcher, and so many other equipments. So yes, rightly pointed out.
Thank you, sir.
Rajesh, Sandeep here.
Yes, Sandeep.
Have we discussed about the energy isolations when we are entering the confined space?
Yes. We have discussed that as a prerequisite for all the confined space entry work. Energy isolation, the draining of residual energy, we did discuss, yes.
Thank you.
Just I want to add the good thing about what you talk about is LOTO, but I think people should go further distance and they should try for LOTO 2, not even LOTO. But the person who is entering, he has to try out whether whatever the controls are placed, they are okay, and the equipment is going to not start. So it is not LOTO, but it is LOTO. That one suggestion to add into this.
Yes, yes, definitely. All the good companies are now implementing LOTO, and that is a prerequisite on the permit itself. We also need to record how and what and how and how we tried out, and that has to be a prerequisite before the issuer issues the permit. Yes.
Yeah, and another good example I've seen, even the effluent treatment plant where we are having the aeration tanks or that kind of thing, those are also classified as a confined space, even though they are not fully closed or something, but the hazards which are the similar, they brings the similar hazards. So some of the examples I've seen during audit, these are also classified as a confined space. I don't know how much it will be taken by all the people, but this is what I've seen.
Yes, yes. In fact, many industries nowadays even open water reservoirs inside a inside a unit. The big water ponds or water reservoirs are also considered confined spaces at times. One of the reason why they are considered is because of the engulfment, entrapment related risk. If there is algae formation, or if there is a entrapment related issue at the bottom where they go, to address that, to be on the safer side, they go for this additional control of applying the confined space permit. Yes.
Yeah, and just to add this one, people are more focused on the manufacturing plant and the equipments, but the other utility buildings or maybe the admin buildings, these are also bringing some kind of
Yes.
confined space as a hazards. If you see the false ceiling, particularly where all the cables and everything is going, so that is also to be considered a confined space.
Yes, the ductings of our HVAC systems, people sometimes enter those ducts and go for cleaning. Yes. Water tanks, water tank cleaning.
Yeah. But it was good session.
Thank you, sir.
Sir, how many people enter at a time in confined space?
There is no such limit defined in any standard. We cannot define such kind of limit. It has to be based on the risk assessment, the JSA, the safe work procedure for that particular confined space, where you have to define what should be the maximum number of people who can be present in a confined space at any given time.
One person is allowed or not?
One person?
One person enter in confined space, allow or not?
Yes. You have an attendant outside, so one person going inside a confined space would not be categorized as a lone working activity. That is the reason why we have a full-time attendant outside always. So there are many cases where only one person goes in for an inspection and comes out. Yes. I mean, the buddy system is not implemented over there. So, I mean, that's acceptable.
Also,
Yes,
I
sir.
would like to tell my one experience about this when we were auditing. In terms of making the inventory, people merely or mostly they see always whatever the confined space they are entering, they will be listed those things only. So they forget, even though they don't enter into that has to be come into the list. Either they enter or not enter, but inventory has to make for all kind of confined spaces, irrespective of entry into those confined spaces.
Yes, exactly. Like, for example, as per law now, the manual scavenging is banned as per law. We have the Manual Scavenging Prohibition Act. So all our septic tanks, we are not supposed to let people enter the septic tank, but then that does not stop us from adding those septic tanks to the list of our confined spaces and putting those signages.
Yeah. And this knowledge is more required now for the municipal corporations, cooperative societies,
And
where
hotels.
this hazards has become very, it is coming up in large scale, because industry,
Yes.
by the time they are aware and they're taking all the precautions. But this is one of the area where the municipal corporations, then most of the scene, you have seen the news particularly people cleaning those kind of septic tank, they are becoming victim.
Always.
So this to be extended knowledge is to be given to these corporations and even cooperative societies where big tanks are there.
Very correct. Very correct. Even I mean, I have, last year I have read a few incidents, multiple fatalities in a hotel septic tank and water tank.
Oh.
Those big 5-star hotels, they have their own used STPs and septic tanks and lot of tanks and vessels. And they do not have a formal safety management system. So they don't have those permit systems and those kind of things. So that is big risk. There is no awareness in those sectors.
And do you suggest this activity in terms of evacuation or the rescue, it should be the part of emergency response plan as well? So when you are auditing emergency response plan, I don't see rescuing from the confined space is covered under any emergency plan.
Yes, ideally it should be. Even the critical work at height activities at any site, not all work at height activities, critical like more than 10 meters, 20 meters, and all the critical confined space entry jobs where we already know the risk of explosion, fire explosion, toxic exposures must be included with proper action plan and response steps mentioned. Or you can have a dedicated procedure which details all of them in detail for each category of a confined space in an industry.
Okay.
Sir.
Thank you, sir. Thank you, other learned professionals here for sharing their views. In cases like remote areas, even in cities, we see a deep borewell drilling happening for 1 day, 2 days, then they leave it open and then go out. In such cases, any probable hazards that can happen, any incident that can happen, anything is trapped, any lively human beings or any animals which are inside, someone goes to rescue. That particular spot is known as some person or a worker getting into the confined space for whom appropriate PPE, including the oxygen levels, if at all anyone is going in such confined space, and appropriately the typical attendant and support with appropriate warning systems in terms of measuring oxygen levels and any sort of a communication between the person who is going inside the deep borewell along with the attendant, that also needs to be kept in view. Plus, there are some times where flooding happens due to heavy rains, etc. The rescue team that goes, we should consider, as we were mentioning about any sort of a vast water or a fluid area in a factory or an establishment. That is also considered as a confined space. Because we see very effluent plant, sometimes it may be very open. People go to either clean or scavenge.
Yes.
Then that also need to be kept in. Thank you. Yes.
Very correct.
Thank you.
Even the thickeners,
Yeah. Yes, sir. Thank you. And I would like to add when you are coming to the end of the session, I thought I will add some few more points for the general understanding. What we spoke about and what you shared with contribution from other participants here, we were talking about typically operational areas in terms of how we can manage what is a confined space and how we can manage a confined space to reduce incidents and fatalities. Having said that, this is an operational area, but there are many other aspects as a satellite support function, so which optimize this confined space management. Number one is the commitment and demonstration from the top management. I'm a very ardent professional practicing ISO 45001 for more than 4 years, and BS has 18001 for more than 6-7 years. And I have implemented many projects in ISO 45001, and I am an IRC approved lead auditor trainer for this. So I have a very close affinity towards ISO 45001. I thought I will add. So coming back to the point, what we discussed now is primarily about practical operational requirements related to confined space, which can be really supported only when the top management dedication and commitment is demonstrated, number one. And number two is management should not consider that, yes, I know the regulations, I know what are the processes from the industry, so I will implement. That sort of attitude must be dropped. And as ISO 45001 says, consultation and participation of workers must be very seriously brought into this confined space management. Plus, ISO 45001, clause number 6.1.0, hazard identification and assessment of risk. This case should be taken as a top priority because if the space is limited, operational level is limited, and rate of incidents and fatality is very high. So hazard identification, if it is effectively made, in addition to normal practices, normal activities, there should be more focus on that. As you rightly said, the competence of the people, clause number 7.2, that also must be focused upon for those who work inside the space and also who go as support and who also monitor this entire system.
Exactly.
7.3 awareness E, clause number in ISO 45001, very clearly says organizations should ensure the workers are aware of how to get out of a hazardous situation or confined space. It's very clearly mentioned.
Correct.
And in ISO 45001, I also came across in Annexure A related to contractors, confined space is very clearly mentioned there. Having said that all, yeah, resources are there, management guidance is there, people are going competent, etc. Very importantly, clause number 9, monitoring and measurement of what is happening in confined space. Manual intervention in terms of working, manual support in terms of attendance and support. In addition to that, we can have some sort of a electronic measures such as what you see in food safety, food manufacturing organization like OPRP, operational PRPs, where, for example, pest control, you keep some sort of a pesticide, some rat comes and takes it. Till someone goes, monitors, a rat is still there. Sometimes it is dead. That is more dangerous in a food manufacturing organization.
Correct.
So they have a system called OPRP where a rat goes into a trap, it starts roaming around. There is an electronic trigger to alarm that there is a rat in the trap. So such systems can also be brought in terms of saving lives in terms of confined spaces. In other words, monitoring and measurement of what is happening and also analyze and evaluate what is really happening in confined space. Very importantly, for all this, very highest level, 2 inputs are there. One from regulatory bodies based on the geographies and the zones, depending upon the industry sector. And very importantly, the next one is the industry practices from the chambers of commerce, industry associations in your specific segment also throw a lot of light because it's like a database or information that has already been explored by them and is available that also can be explored to have optimized the confined space. Thank you very much, Mr. Rajesh, for your wonderful session, bringing more and more practical inputs in terms of operational controls in confined space. So thank you especially very much, and thank you KBS for this session and all other learned professionals who contributed. Thank you, sir.
Thank you. Thank you so much, sir, for being so interactive and sharing your experiences and knowledge.
Welcome, sir.
I'm looking forward to more such sessions and interactions with you, all of you, in future.
Please. Thank you.
Vandana, are you still around? I don't think so. Okay, in that case, we can call it a day.
Yeah.
Thank you all again. Enjoy your weekend.
Oh, yeah.
Have a safe weekend.
Thank you,
And
sir.
please give your suggestions on, other trainings and any such other subjects or topics so that in future we can have more such interactive sessions.
All right. Sure, sir. Thank you.
Thank you.
Thank you.
Thank you so much.
Have
Goodbye.
a nice evening. Goodbye.
Thank
Goodbye.
you, sir.
Thank you.
Thank you.
Thank you, sir, for wonderful sessions.
Thank you.
Thank you so much, sir.
Session.